So let's do the 17th sum, the last sum in textbook in rotational motion. The oxygen molecule has a mass of 5.30 into 10 to the power minus 26 kg, and that's this mass. And a moment of inertia is 1.94 into 10 to the power minus 46 kg meter square. And it's going to rotate about an axis which is perpendicular to the line joining the two atoms. Suppose the mean speed, so it's going to spin like this, okay? So mean speed of the molecule is also been given, velocity, which is 500 meter per second, and its kinetic energy of rotation. Kinetic energy of rotation means rotational kinetic energy, which is half I omega square, is 2/3 of the kinetic energy of translational. Translation is half mv square. This and this get cancelled, hence you can get the two can go up. You can get a new formula for omega square with a 2/3I and an mv square, and so equating this you get this, and you can find the square root of this, which is root of 2/3im into v, and that's the formula. And you know the linear velocity, which is here, which is given, and mass I, moment of inertia, everything has been given. Just substitute and get the value of omega and write the answer in radians per second. And that's the last question. Let's go to previous question. A meter stick, 1 meter, is balanced by a knife edge exactly at the center, which means there's a 50 centimeter here and a 50 centimeter here. Okay, now they are putting two coins, one above the other, each of 5 grams, so put together 10 grams. Is placed 12 centimeter from one end. So it's if it's 12 centimeter from one end, the stick is found to be balanced at 45 centimeter. The shift in the center of mass is happening here at 45 centimeter. So it's 45 minus this 12, which will make this a 33 centimeter, and this distance will be 50 minus 45, so another 5 centimeter here. And since this was the original center of mass, where the entire weight of the scale was concentrated downward, the entire weight of the scale is given to be, that's the question, you have to find the mass of the scale and the gravity, and that will be acting down. If that's going to be acting down, okay, and you have this 10 gram which is going to be acting down with again a mass of with a gravity of 9.8. So you have a 10 grams which is going to, that's grams, that's not gravity. So 10 into 10 to the power minus 3, or if you're going to keep it in CGS unit, you can keep it. So 10 into 9.8, yeah, there will be another G which is going to pull it in this direction. And this is, let's call it W1, let's call this W2, and according to Lever principle, W1 into this distance, which is 33, is equal to this W2 into this distance, which is 5. And so then you will have an M into G, which is actually 10 into G into 33 is equal to the mass of the scale into G into 5. G and G get cancelled, so we can just find M to be 330 by 5. So the answer is 66 grams is the mass of the entire scale. So let's go to next question. Is this which is the 15th question, where you have a uniform circular plane of radius r, capital R, from which you are actually cutting an r/2 radius, a radius of r/2, you're cutting it out and throwing it away. And therefore you know that the center of mass, with the initial center of mass was at the center, which is the origin, it will now be shifted towards the left somewhere. If you're going to call this as O, you know this is your O1, which is the center of mass of the removing piece. The center of mass of the balance piece will get shifted like this, and you can simply do this sum with the left moment is equal to right moment. Moment is mass, and you don't know the mass is surface density. Surface density into pi into capital R square minus pi into r/2 the whole square, which is r square by 4. This will be the mass of this crescent part, into the center of the position from the center is equal to mass of the circular part, which is sigma into surface charge density into pi surface density into pi into r by 2 the whole square into that distance, which is 001. You already know that 001 is r by 2. You already know, so you sigma get cancelled, pi get cancelled. It is r square minus r square by 4 into 002 is equal to r square by 4 into r by 2, because 001 is nothing but the radius of the smallest circle, so it will be 4 of r cube by 8. 002 is 4 r square, which is 3 r square by 4. 4 and 2 get cancelled, r square and r get cancelled. Thus 002 is 3 by 2 by 3, 3 by 1 by 6, 1 by 6 of r, or r by 6, and that's the answer. That's how it's getting shifted. I just used the formula of lever principle. Left moment is equal to right moment. Let's go to next 14th question. The 14th question, to maintain a rotor of uniform angular speed omega is 200 radians per second, an engine needs to transmit a torque of 180 Newton meter. What is the power? You should know what is power's formula. Power's formula, P is equal to, power is generally force into velocity, but in rotational motion will be torque into omega. So this gets changed, and torque is 180 and omega 200. You just simply multiply it, you get 36,000 watts or 36 kilowatts to be the power here. So let's go to next question, 13th. A rope of negligible mass is wound around a hollow cylinder. So let's take a hollow cylinder, rope of negligible mass wound around a hollow cylinder. The mass of the hollow cylinder is 3 kg. The radius of the hollow cylinder r is given to be 40 centimeter. What is the angular acceleration of cylinder? The rope is pulled with a force of 30 Newton. This is going to be pulled with the rope of the force of 30 Newton. You can find the torque of the torque with which the cylinder will rotate, which will be this force into the radius perpendicular distance, which will be 30 into the radius is 0.40 meters, and so it will be 12 Newton meter. Thus you found the torque, the rotation of the cylinder. Once you find the torque, they're also asking you to find the angular acceleration. You should know that T is equal to I alpha, so that you can find alpha is T by I. What is T? T is the 12 Newton meter that you found. I is moment of inertia for hollow cylinder. This is going to rotate about an axis which is like this, which is similar to a hollow cylinder rotating like this, which is just mr square. So it's m into r square. And you can substitute those values. What is m? M is the cylinder's mass and r is 0.40 the whole square. So you will calculate that value will turn out to be 0.48 kg meter square, and that's, just substitute these values and you'll get this answer to be 25 radians per second, the calculated value. Then they're asking linear acceleration. You know the relation between linear acceleration and angular acceleration. A linear acceleration is r times angular acceleration, and you know the radius here. Radius is 0.40 and the 25, so multiply it, you get 10 meter per second square to be the linear acceleration. So let's go to next question. It's the 12th question. The 12th question is a child stands at the center of the turnable table, the round table, stands at the center with the two arms stretched out. Two arms are stretched out, you know that the radius is more, the angular velocity will be less, and the radius is less. If it's going to be holding its hand, radius is less, the angular velocity will be more, and that was proved by the angular momentum remains conserved in the absence of external torque. Torque is zero. Torque itself is dl by dt. This is the angular momentum remains conserved when t is 0, because L has to be a constant. So it's, what is L? L is I omega. Angular momentum is r times linear momentum. No, you just have to write L as I omega. So it's I1 omega 1 is equal to I2 omega 2. You can also write L1 is equal to L2. R times linear momentum m1 v1 r1 is equal to r2 into mass will remain the same. It's the same person, no? V1 and M into V2. M and M get cancelled. And you know that this is R times angular velocity, R1 into omega. So you get to be R2 into R times linear velocity is R times angular velocity, omega 1 and omega 2. So you get an R1 square and R2 square. And you can multiply both sides with mass. Mass need not have cancelled. You could have retained the mass because you want mr1 square is I1 omega 2 is equal to mr2 square is I2 this is omega 1 and this is omega 2. So I1 omega 1 is equal to I2 omega 2. In other words, if the radius is more, the angular velocity is less and vice versa. So then I just thought I'll recall that. Now this sum is not about that. Let's see what is this question. So you have a child standing on this turnable table with the arms stretched out. The turntable is set in rotation with an angular speed of 40 rotations per minute. Whenever they say rotations per minute, no, I prefer to have it as radians per second, because omega should be not in rotations per minute, should be radians per because this rotation per minute means it's frequency. The fact that 40 rotations per minute is frequency, not omega, and omega is 2 pi mu, so it's 2 pi into 40, 80 pi radians per second is what is omega. So how much is the angular speed of the child if it folds his hand back and thereby reduces the moment of inertia to 2/3 its original value? It's I1 omega 1 is equal to I2 into omega 2, and you know that the I2 is going to be reduced to 2/3 its initial value. So 2/3 of I1 omega 2 is I1 into omega 1, and I1 can get cancelled. So omega 2 is what they are asking is omega 1 into 3/2. What is omega 1 is the angular velocity, which we found it to be 80 pi. 80 into pi into 3/2 is 40, so 120 pi. That will be my omega 2. Am I making any mistake? Let's see. They've given that it's 2/3 times the initial value. Which one reduces its moment of inertia? The resultant moment of inertia when it folds his hand, 2/3 of I1 get cancelled. Omega 1 is 2/3 of omega 2. So omega 2 is 3/2 of omega 1. At 3/2 of omega 1 is the initial radians per second, which is 80 pi. So I'm getting a 120 pi radians per second to be omega 2, but what is given here is the question is wrong. Here it says 2/3. In Aurora, in the question it says 2/3. In answer it shows 2/5. So my answer is correct if the question is 2/3. Okay, and then thus we found the final angular velocity. Second part of the question, show that the child's new kinetic energy of rotation is more than the initial kinetic energy. How do you account for this increase in kinetic energy? The initial kinetic energy is half I1 omega 1 square, and the final kinetic energy is half I2 omega 2 square. Correct? And so then the initial kinetic energy of rotation is half into this is this, and this is 2/3. No, it's 2/3 of I1 into omega 2 square, and you know that omega 2 square is 120 pi. You can substitute it here. And this one is, the value is 80 pi. They're asking for the ratio of this to this. So in that case, when you divide half I1 omega 1 square by half 2/3 I1 omega 2 square, I1 get cancelled, 1/2 get cancelled. You know the respective values of omega 1 and omega 2. It's 80 pi the whole square by 120 pi the whole square. Just make sure that you're cancelling all this and writing your answer. Pi square directly get cancelled. 80 into 80 by 120 into 120. The Aurora's answer will not tally with mine because there seems to be a printing mistake. That's the child's, this is old kinetic energy is to new kinetic energy. Okay, so it's you get an answer which is in decimal number. So you understand, it's 2.5, which means it's a loss of energy. The new kinetic energy is greater than the Oh no, this is I did old versus new. Okay, old versus new, the denominator is more. Can you see it's 1 by 2.5? Or okay, new versus old will be 2.5, which shows that the new kinetic energy is greater than the old kinetic energy. And how do you explain that phenomenon? The increase in the kinetic energy is due to the internal energy of the child, which he used in folding his hand. Okay, imagine, no, if you're folding your hand, you need less energy. When if you're stretching out your hand and rotating, you need more energy. So you're saving energy by folding, and that it can be explained. So that makes it very simple explanation. So let's go to 11th question. A solid cylinder of mass 20 kg rotates about its axis. That's a solid cylinder though. Solid cylinder moment of inertia is mr square by 2. A solid cylinder of mass 20 kg rotates about its axis with an angular speed of 100 radians per second, then omega itself has been given. The radius of the cylinder is 0.25 meter. What is the kinetic energy associated with the rotation of the cylinder? Whenever they ask you kinetic energy, it's rotational kinetic energy. In this case, if it is sliding down inclined plane, there will be rotational as well as rectilinear. Okay, translatory, whatever. Then in that case, it's half I omega square plus half mb square has to be added, total energy. But in this case, it's only spinning about the vertical axis, so kinetic energy is half I omega square. But I itself is mr square by 2, m, r square, substitute all the value, get this. Once you get the moment of inertia of 0.625 kg meter per kg meter square, mr square. Take that and substitute it here, omega itself is 100 radians per second. Substitute all that, you get this value, 3125 joules is the kinetic energy. So once you get the kinetic energy, they are also asking for angular momentum. You should know that angular momentum is I into omega. Moment of inertia, which has already been calculated here, and omega, just write that and you get the angle. Supposing you forget what is L is equal to I omega formula. You write angular momentum is R times linear momentum. Write as R into mv. Write V as R into omega. So mr square into omega, which is I omega. Just remember this because there's a possibility that you can forget it. So then, respective values, you can just substitute it and get the answer. Moment of inertia is 0.625 into omega itself is 100, and so you get an answer 62.5 kg meter square per second, because it's angular momentum, which is r times linear momentum. Momentum is mass into velocity, kg meter per second. Another meter is there, so kg meter square per second. So kg meter square per second is unit. Okay, let's go to next question. Next is the 10th question. A torque of equal magnitude is applied to a hollow cylinder and a solid sphere. Hollow cylinder having both mass and same mass and same radius, that's good. The cylinder is free to rotate about its standard axis of symmetry. Okay, it's a hollow cylinder, whereas a solid sphere. You should know the moment of inertia of hollow sphere, I is equal to mr square. Moment of inertia of a solid sphere is 2 by 5 of mr square. You should know this, especially if it's rotating about an axis through the center. Can you imagine, no? So it's 2 by 5 of mr square. So these two formulas you already know, left hand side, right hand side, okay? The cylinders, but both of them are succumb to the same torque. They are of the same mass, they are of the same radius, they are succumbing to the same torque. Which of the two will acquire a greater angular speed after a given time? I1 is equal to m1 r1 square, I2 is equal to 2 by 5 of mr square, 2 by 5 of mass and radius are the same. Okay, so then they're asking about which one will acquire greater velocity. All you know is you can find acceleration and angular acceleration. Torque is equal to I alpha, from which you can write alpha is equal to T by I. Torque is just the same. So then alpha is inversely proportional to moment of inertia. And the moment of inertia for this one is mr square. And for the second one, it's 2 by 5 of mr square. The fact that it's 2 by 5 makes it 5 by 2 on the top, and it becomes 2 by 5, and the torque is greater. You know that this torque is greater. Torque is equal to I alpha. So alpha is equal to T by I. torque is alpha is inversely proportional to moment of inertia, because torque is the same. Alpha is equal to T by I. Torque is the same, moment of inertia. So then alpha is inversely proportional to moment of inertia. Since this moment of inertia here is 2 by 5, it becomes 5 by 2. Okay, the moment of inertia 2 by 5 shows that the moment of inertia is less. So moment of inertia is less, the acceleration is more, therefore the sphere will have a greater acceleration. So the solid sphere will have a greater angular velocity and angular acceleration also. So let's go to next question. So the next question is the 9th question. A car weighs 1800 kg. The distance between the front and the back axle is 1.8 meter. Its center of gravity is 1.5 meter behind from the front axle. This is the front. This is the back. 1.05. Not exactly middle, because middle means 0.9. So 1.05. This is where your 1.05 meter from the front axis is where my center of mass is. The whole length is the whole distance is 1.8 meter. But which shows that most of the mass is situated only at the back. That's why the center of mass is also shifted towards the center of gravity, center of mass. Symmetrical body, both of them will coincide. So determine the force exerted by the level ground on each front wheel and the back wheel. So there is a, this is the car, means this is front wheel and there's a back wheel, this axis. There will be a normal reactions here, which will be your R1 and your R2 for the front wheel and the back wheel. And the distance of it from this side is 1.05. This side will be 1.8 minus 1.05, which will turn out to be 0.75. And you can just say that left moment is equal to right moment. This R2 into 0.75 will be equal to this R1 into 1.05. So then you will get it like this. You get your first, this is one equation you will get. You also know that the entire body of 1800 will act downward, totally act downward from the center. There will be a total weight W, which is R1 plus R2, the both upward forces, R1 plus R2 will be equal to 1800. So 1800 into gravity into 10, so 18,000. So R2 can be written as 18,000 minus R1, and you can substitute this value here. The 18,000 minus R1 into 0.75, consolidate and then just find the value of R1. So once you find R1, put it here and find the value of R2. So let's go to next question. The next question is the 8th question. A non-uniform bar of weight W is suspended by a rope like this and also a rope like this. This rope is making an angle of 53.1 degree, while this rope is making an angle of 36.9 degree. It's a smaller rope and that's a larger rope. It's non-uniform, which means it's not, you can't say that the center of mass is exactly at the middle. This is a 2 meter rod, and you know that you don't know where the center of mass is. You can assume it like this, where if this is D, this is 2 minus D. Okay, so that's where you are assuming the center of mass to be. Calculate the distance of the D, where your center of mass or center of gravity is from the left side. So in this, the advantages, you have a T1 and you have a T2, which will get broken down into, with the vertical you have to assume as theta. So it's T1 cos theta. This is phi, okay. This is theta, means this is theta, and this is T1 sin theta. T2, this is T2 cos phi, because 53.1, and this is T2 sin phi. Break them down, and you also know that there will be a W which is acting downward, okay, through the center of mass. There will be a W. So then you're going to use resolve the vectors. If this system is going to be in equilibrium according to the question, left vector is equal to right vector. T1 sin theta is equal to T2 sin phi. That is my equation number 1. Up vector is equal to down vector. A T1 cos theta plus T2 cos phi will be equal to W. That is my equation number 2. So now what you do, you also write left moment is equal to right moment. Right left moment is t1 cos theta into this distance d is equal to right moment t2 cos phi into this distance. So t1 cos theta into d is equal to t2 cos phi into 2 minus d. Once you do this, you can mark this as equation 3. Now make sure you're dividing 3 by 2. When you do that, the advantage is 3 by 1, right? Divide 3 by 1. The advantage is t1 and t1 get cancelled, and t2 and t2 also will get cancelled. You will have a cot theta into d is equal to cot phi into 2 minus d. So you know that what is theta and you know phi. Substitute the respective values and then consolidate and find d. Of course you can't do because these are unknown angles, 53.1. So if there's known angles, you can substitute and get the answer. Let's go to next question. Is the 7th question, where two particles each of mass m and speed v travels in opposite direction along parallel lines separated by distance d. So then there is a mass which is traveling m1 traveling in this direction. There's an m2 which is going in this direction, and a parallel line separated by distance d. Okay, show that the vector angular momentum of the two particles is the same whatever be the point at which the angular momentum is taken. So then let's see, I think we can take it like this, no? Actually we can take it like this is spinning like downward direction, this is spinning in upward direction. Can we take it? Because there has to be some spinning for me to find if the word angular momentum or angular velocity is there has to be rotational motion. So supposing this is at a distance x from the origin, this is my y-axis and this is my x-axis, okay? So in that case, I can write that a moment of inertia I is I1 plus I2, the moment of inertia of the first one, and this is d. So then from the origin, the second one will be x plus d. First one will be at a distance of x. So moment of inertia is, let's write it as a vector. It's I1 plus I2. No, this is angular, so no, not moment of inertia. Let's write angular momentum L is equal to L1 plus L2. Because the question is not about inertia, angular momentum L is equal to L1 plus L2. So R into P1, that's cross product. So R1 cross P1 plus R2 cross P2. What is R? Position vector, which is x into I cap, cross momentum is mass into velocity, which is which direction is negative. It's coming down, right? It's coming down. So it's negative y direction. So we can say minus mv into j plus r2. For the next one, it is x plus d into I, and the cross momentum is again mass into velocity, agreed, but the distance of x plus d, and which direction is going upward, so it's positive and can write it as j. Okay, so you're going to solve this separately and these two separately, okay, these two combined. So when you solve this, an I cross j is there. What is I cross j? I, j, k. I cross j is k, so it will be mvx with a k cap and a negative sign shows that it's negative z direction. And look at this, you're going to cross an I cross j. What is I cross j? Again it's a k but positive k. So you get mvx into I and mv. Okay, look at this. This is the position vector. So the mass into velocity into j. There's no x plus d here, sorry. The position is here and mass into velocity into j. So mv into x plus d into I cross j itself is k, and you can take it in mvx plus mvd with a k and a k. So this and this will get cancelled. So your answer is mvd. D with the positive k direction. Such a difficult question this is. Clearly, L does not depend on x because it's independent of x. Can you see it only depends on the distance between the two particles and it's not dependent on x. This angular momentum of two particle system is same whatever the point about which the angular momentum is taken. So some weird question. This is according to me very tough question. So let's go to sixth question. Sixth question is they have given moment of inertia is Ix into I plus Iy into j plus Iz into k. No, that's not moment of inertia, angular momentum. Sorry, L1, L2, Lx, Ly and Lz, angular momentum. Then a position vector is also given to be xi plus yj plus zk. Then momentum is given to be pxi plus pyj plus pzk. This is called, writing like this is called writing it as a rectangular components x, y, z. Okay, so then show that the particle moves only in xy plane. The angular momentum has only z component. You write what is angular momentum is r cross linear momentum. So put it in put it as I, j, k. What is r? X, y, z. What is p? Px, py and pz. Just do a cross product. When you do it, you know I into minus j into plus k into. When you do I into, you ignore that row, that column. So y into pz minus py into z. Next term, when you do minus j into, you ignore that row and that column and do top to bottom minus bottom to top. So you know it's py into z minus j into x into pz minus px into z. K into that row, that column has to be omitted and top to bottom minus bottom top, x into pz minus z into px. So thus you get this, and once you get this, comparing the coefficients, you have to compare this coefficients with L's coefficients. What is L? Lx, x into I plus Ly into j plus Lz into k, and equating both their coefficients, you know, you get Lx to be ypz minus zpy. When you cross multiply zpy, no, zpy. So then minus, then iy, you can, ly, you can write it, but you have to switch this because there's negative sign. So it's px into z minus pz into x. Then you know Lz is x into pz minus z into x into py again, py minus y into px. You do the determinants properly, you will get the answer. You can check Aurora. Sorry about my bad handwriting. So then x into py minus y into px. Z will have y and x. Y will have z and x. X will have z and y. Remember that. Okay. So in this case, you know that it is, if the particle is constrained to move in an xy plane, when the particle is moving only in an xy plane as given in the question, z will be always 0. Z will be 0. And so then this pz, or what to say, if the particle constrained to move only xy plane, then z is equal to 0 and pz is equal to 0. Wherever pz is, it's going to become 0. It will only have this one because this only doesn't have pz. So as only the unit vector k corresponding to z direction survives, all the other is getting cancelled. The angular momentum has only z component. This again, this I find it very difficult. Okay. So then the next question. Next question is the fifth question. Fifth question is about show that A dot B cross C is equal in magnitude volume of the parallelepiped formed by the three vectors ABC. So what is a parallelepiped? You should know what is a parallelepiped. It's a parallelogram. You know the parallelogram is like this. A parallelogram, if you see the parallelogram, if you consider this to be the origin, you have an OX You have what to say, you can call this A vector, this you can call this as B vector, and you can call this as C vector. Can you see all of them emanating from the origin? This one, do it in red color, this one, and this one. So you have three different vectors A, B, C, and the area of the volume of the parallelepiped is given by A dot B cross C, and so you have to draw it like this. And what are they doing is they're taking A dot B cross C, and they are for what is the formula for B cross C is magnitude of B into magnitude of C into sine theta. But there is a dot product and then only a cross product is there. First, let's apply the formula for dot product, which is magnitude of A into magnitude of B cross C into cos theta. Now, therefore, you can just write this along with this. You have a B cross C with the magnitude of A into cos theta. A B cross C is the base area of a parallelepiped. This is the area of parallelogram, which itself is base area, which is a parallelogram, into an A cos theta is the height of the parallelepiped, parallelepiped, or whatever you call parallelepiped. Okay, so then it's base area into height. So volume of the parallelepiped have the vectors A, B and C along edges meeting at the point. Okay, so what do you understand? So this is the base area and this is the height of the parallelepiped. So can you see for a cuboid also, the base area into height will give you the volume. So this is, when you do this, when you apply this formula, you're able to prove that you're getting the volume. So that's about this question. So next question is the fourth question. Show that in a triangle, show that the area of the triangle containing sides A vector, this is A vector and this is B vector, is 1/2 of the magnitude of A cross B. So area of the triangle is magnitude of A cross B. To prove this, a very, very interesting question. So what you do is to just take A cross B, magnitude of A cross B, take it and write it as magnitude of A into magnitude of B into sine theta. Okay, when you do this, what is magnitude of B sine theta? Magnitude of A vector is OP. Let's consider it as OQ. Okay, let's consider this as OQ. So then this is OP, and this itself is B sine theta. If we're going to consider this as the theta and this is some n, that itself will be Qn. So where you know that when you do sine theta is equal to Qn by B, a B sine theta itself is becoming a Qn. So I can write this as Qn. So I got the OP and a Qn, which is the base and the height, and I just need a half because area of a parallel triangle. So multiply and divide by 2. So take the 2 out and write half into base into height, which is equal to, where did you start with? The magnitude of A cross B. So bring the 2 down. Therefore the area of a triangle has now become a magnitude of A cross B by 2. Very beautiful way of doing it. So let's go to next question. The third question. A child sits stationary at one end of a long trolley which is getting pushed here. The child is sitting on one end and the child will try to move. Will it affect the speed of the trolley? Even though the center of mass is getting shifted as the child moves, because the child, the whole system is trolley plus child, and any change in the internal system will not attribute to the change in the velocity. There is no external force here, no external force. The child only is moving, which is only a change in the internal system. So since there is no external force, there will be no change in the velocity. So that's the question that's answer for the third question. So let's go to second question. This in HCl molecule, the separation between the nuclei of the two atoms is about 1.27 Armstrong. So there's a H and a Cl and the distance is 1.27 Armstrong. You have to assume immediately this as the origin, so you get this to be at the origin and this to be at 1.27 comma 0. So you know the center of mass, this is H and this is Cl, and chlorine is much heavier, it will be shifted towards the right. And in the HCl molecule, the separation, find the approximate location of center of mass given that the chlorine atom is about 35.5 times massive. So then chlorine is 35.5 times massive as hydrogen. And you know, to find the center of mass, it's weighted average m1 into x1 plus m2 into x2 by m1 plus m2. What is m1? Mass of the hydrogen 1, position vector origin 0, plus m2 mass of chlorine, which is 35.5, into position vector 1.27 by m1 plus m2 is 1 plus 35.5. Thus you get 1.235 Armstrong to be the center of mass. Unless you fix the origin at the left side, you can't get this answer. So let's go to the first question. Given the location of the center of mass, for a symmetrical body, the center of mass will be at the center. For a cylinder, the center of mass will be at the geometric center. Correct? You join the diameters, the point where the diameters meet. Here, just join the height and the draw a line across the center. For a ring, you know, like a tenicoid ring, it can be join the diameter, it can be outside the body, center of mass. And then for a cube, it's a geometrical center, right? And how do you do that? You just have to, you have to join that and this. You have to add that end and this end, and the points where the diameters meet will form the geometric center, which is the center of mass. But the question will be about a cone, because you would have forgotten about a cone. The center of mass will be h by 4. H by 4? H by 4. So then that's where this height is, and this will be therefore h minus h by 4. That's where the center of mass of the cone will be located.